Hello, my name is Michael Hegehorst, and today I'd like to talk to you about lazy evaluation. So the way I'd like to present this is I'm going to give you a quick rundown on what lazy evaluation is and what it's used for, and then I'd like to show you some worked examples in Haskell as well as Python. So to start off, what is lazy evaluation? Lazy evaluation is the opposite of eager evaluation, and eager evaluation is the type of evaluation used in most programming languages. So in C++, as soon as you write the variable x, int x is equal to 2 plus 2, 2 plus 2 is evaluated and saved into x as 4. Lazy evaluation, on the other hand, is only evaluated when needed. So instead of immediately saving 4 into x, the information will not be processed until x is accessed in red. And there are many advantages to this type of evaluation. It allows for infinite data structures, such as infinite lists, and it also allows for reduced calculations. So it only does the calculations required in order to complete the goal, complete the program, and so you don't have any wasted calculations. There are a few languages that use lazy evaluation, including Haskell and many other functional languages, and other languages such as C#, Python, and Java with some tweaking are able to use lazy evaluation as well. So let's jump over to Haskell and I will show you an example of lazy evaluation and its usage. So I've jumped over to Visual Studio Code where I have an interactive Haskell environment running, and this works very similarly to the Python terminal, where we can type in the Python terminal and get results from Python. So I can do something like 2 plus 2, and that's going to print out 4. Haskell also allows for quick list building, so I can do something like 1 to 100, and it's going to build a list for me from 1 to 100. I can also do something interesting, like let's say I say 1 to I'm not going to put a number there. Let's see what happens. And you'll see we're starting to spit out just a ton of numbers. And this is an infinite list. This is one of the advantages of lazy evaluation, is that we can build infinite data structures such as infinite lists. And this list would just keep going and generating new numbers until I tell it to stop. And this can be very useful. For example, if I want to get the 100th even number, I can say, let's go from 2 to 4 and then index it at 100. So now we know that the 100th even number is 202. Or I suppose that would be the 101st, since indexing starts at 0. And we can also, in the environment, assign lists to variables. So let's say x is equal to an infinite list, and I'm going to have to cast this to a list of integers so the environment remembers what it is. And if we inspect x right now, we can see that x hasn't been evaluated yet. That's what that little underline means. X is unknown. So let's say I want to get the item at the third index from x, which is going to be 4. And now if I inspect x, you'll see that it has evaluated up to the third index. And this is really useful. I can now evaluate x all the way up to, like, let's say the 6th index. And if we inspect x again, you will see that it has evaluated more of x. And I can just index x at any location I want, like let's say at 100, and Haskell will only evaluate x up to that point. And that's really useful for anything such as getting the 100th Fibonacci number to any number of possible usages. So to wrap things up, I'm going to show you how to do lazy evaluation in Python. Here we have a particularly expensive function that generates a list of numbers from 0 to 9. And there's a half-second wait between each of them. This is not a very realistic function, but there are some calculations that are expensive and could take time like that. We want to break after finding the number 3, so we're not using most of the variables generated by this function, which is why lazy evaluation is useful here. So you'll see that if we run this function, if we run this script, we output the numbers one at a time, and then we find 3. And this is useful because we don't have to generate all 10 numbers. We only generate the first 4, 0 to 3, and then we're able to cut out. So I hope you've learned something about lazy evaluation. It is a very powerful technique available in multiple languages, and I hope you're able to use it at some point in the future.